Astronomers first detected 3I Atlas in late 2024, a faint streak against the starry backdrop, captured by ground-based telescopes and confirmed by space observatories like SphereX and the James Webb Space Telescope. This chapter delves into the initial observations, tracing its hyperbolic path from the depths of interstellar space, far beyond the Oort cloud. Unlike previous visitors, such as 1I Oumuamua and 2I/Borisov, 3I Atlas exhibits a coma of gas and dust, suggesting cometary activity, yet its velocity and composition raise immediate red flags. Scientists analyze spectral data, revealing unusual molecular signatures, possibly including exotic ices not found in our solar system. The narrative builds tension through accounts of the Discovery team's mounting realization that this object is no ordinary comet. Its size, estimated at several kilometers, and erratic brightness fluctuations suggest internal processes at work. As data pours in, discrepancies in its predicted path emerge, hinting at gravitational influences or self-propulsion mechanisms. The chapter explores the historical context of interstellar objects, emphasizing how 3I/Atlas fits into a pattern of cosmic anomalies that question the isolation of our solar system. Yet, beneath the scientific veneer lies a deeper unease. Early models predict a close solar approach, but subtle deviations challenge these forecasts. 248 words. Symmetry, but what hidden force could be altering its course, drawing it inexorably closer to permanence in our celestial neighborhood? As 3I/Atlas hurtles toward perihelion, its trajectory defies conventional orbital mechanics, prompting intense scrutiny from orbital dynamicists worldwide. This chapter examines the hyperbolic orbit's parameters, calculated to exceed solar escape velocity, yet recent observations indicate a potential slowdown, as if an invisible hand tugs it back. Data from radar tracking and astrometric measurements reveal non-gravitational accelerations, similar to those seen in Oumuamua but amplified, possibly due to outgassing or asymmetrical heating. Scientists debate whether these forces stem from natural sublimation of volatiles or something more artificial, with simulations showing a slim chance of gravitational capture by Jupiter or the Sun itself. The narrative unfolds the step-by-step analysis of ephemeris data, highlighting discrepancies between predicted and observed positions that grow with each passing week. Interviews with experts, including theoretical physicist Michio Kaku, underscore the implications. A captured interstellar object could disrupt planetary equilibria or introduce foreign materials into the inner solar system. Tension mounts as the chapter details real-time monitoring efforts by NASA, revealing classified briefings on contingency scenarios. Yet, the orbit's instability suggests it could fragment or alter course unpredictably during its solar flyby. Probing deeper into 3I/Atlas's physical makeup, this chapter dissects spectroscopic analyses that paint a portrait of an object forged in alien stellar nurseries. Infrared and ultraviolet data from JWST expose a surface rich in organic compounds and rare isotopes, differing markedly from solar system comets. The presence of a dust tail and gaseous coma indicates volatile ices evaporating under solar heat, but anomalous elements, perhaps heavy metals or unknown hydrocarbons, hint at a birthplace around a distant metal-rich star. Researchers compare it to known interstellar mediums, drawing parallels to molecular clouds in the Milky Way's disk. Yet peculiarities like its elongated shape and tumbling rotation suggest a violent ejection from its origin system. The summary builds suspense through detailed examinations of brightness variations, interpreted as possible structural instabilities or active venting. Michio Kaku's insights frame the discussion, positing that such compositions could imply panspermia or even technological artifacts embedded within. As the object nears the Sun, enhanced observations reveal subsurface layers through thermal imaging, raising questions about internal heat sources independent of solar influence. The chapter culminates in the revelation of inconsistent density estimates, suggesting hollow regions or artificial constructs. Amidst its approach, 3I Atlas has begun emitting sporadic bursts that confound astronomers, from magnetic pulses to faint radio anomalies detected by arrays like the Very Large Array. This chapter investigates these phenomena, starting with the initial detection of a magnetic field stronger than expected for a natural body, potentially indicating metallic cores or dynamo effects. Spectral lines show unexplained shifts, possibly from relativistic effects or internal energy releases. Experts analyze waveform data, ruling out solar-wind interactions but struggling to explain pulse regularities that mimic patterns in pulsar emissions. Yet, artificial in subtlety. The narrative heightens intrigue by exploring hypotheses of cryovolcanism or chemical reactions, contrasted with wilder theories of encoded signals from extraterrestrial origins, as speculated by Kaku. Real-time telemetry from probes like Parker Solar Probe adds layers, capturing transient plasma disturbances in the object's wake. As emissions intensify with solar proximity, correlations emerge with orbital deviations, suggesting a feedback loop. The chapter probes the scientific community's divided responses, from skepticism to covert investigations into signal decryption. Yet, the pulse's origins remain elusive, defying models of natural astrophysics. Tracing 3I Atlas back to its cosmic cradle, this chapter explores competing theories on its provenance, from ejection by a binary star system to gravitational slingshots around black holes. Backward trajectory modeling points to the direction of the constellation Lyra, potentially linking it to nearby stellar clusters, but uncertainties in galactic motion blur the picture. Compositional anomalies suggest formation in a protoplanetary disk unlike our own, rich in exotic elements that challenge standard stellar evolution models. The summary delves into panspermia implications, positing that microbial life or precursor molecules could hitch a ride, altering our understanding of life's universality. Kaku's theoretical frameworks introduce quantum possibilities, such as wormhole transits or advanced propulsion residues. Tension escalates with discussions of artificial origins, drawing parallels to Oumuamua's controversies, where light-sail hypotheses linger. Astronomical surveys for similar objects reveal a potential population of interstellar wanderers, implying our solar system is not as isolated as once thought. Yet, the object's pristine condition after eons of travel defies erosion models, hinting at protective mechanisms. As perihelion looms, simulations increasingly predict a non-zero probability that 3I Atlas could shed enough velocity through outgassing or gravitational perturbations to become captured in solar orbit. This chapter scrutinizes these models, detailing how close encounters with inner planets might alter its path, potentially inserting it into an elliptical orbit crossing Earth's. NASA's internal assessments, leaked through anonymous sources, express terror at the prospects. Orbital debris hazards, atmospheric contamination, or even collision risks over millennia. The narrative unfolds the physics of orbital capture, from three-body interactions to aerobraking effects, emphasizing the razor-thin margins between escape and entrapment. Kaku warns of broader implications, such as destabilizing the asteroid belt or influencing climate through dust influx. Observational campaigns intensify, with telescopes worldwide tracking for signs of fragmentation that could facilitate capture. The chapter builds dread through visualizations of long-term orbital evolutions, showing potential resonances with Jupiter that could lock it in place. Yet, predictive uncertainties persist, fueled by the object's unpredictable behaviors. Behind closed doors, NASA grapples with the terrifying ramifications of 3I Atlas's potential permanence, from resource allocation for prolonged monitoring to international protocols for interstellar threats. This chapter exposes declassified memos and expert testimonies, revealing concerns over electromagnetic interference with satellites or unintended biosphere interactions if fragments reach Earth. global observatories collaborate, yet tensions arise over data sharing amid fears of public panic. The summary probes the psychological toll on scientists as anomalies mount without resolution, echoing Cold War-era asteroid defense strategies. Kaku articulates the existential dread. An object that defies nature could signal surveillance or harbinger worse intrusions. Implications extend to astrobiology, questioning contamination risks, and to defense, pondering militarized responses. As the sun's gravity tests its integrity, predictions of survival vary, with some models forecasting disintegration and others a resilient core enduring. The chapter heightens suspense by detailing contingency plans, including probe redirects for close inspection. Yet, the agency's silence fuels speculation, leaving the world in suspense. In the wake of its solar encounter, 3I Atlas leaves a trail of unresolved enigmas, from its true nature to the shadows of what may follow. This final chapter synthesizes lingering questions, reviewing post-perihelion observations that could confirm capture or reveal new anomalies. Future missions, like proposed interceptors, promise closer scrutiny, but timelines stretch into decades amid funding battles. The narrative reflects on how this event reshapes astronomy, urging a reevaluation of interstellar traffic and our place in the galaxy. Kaku's closing thoughts emphasize the unknown. If one such object arrives with peculiarities, others may lurk undetected. The chapter explores broader cosmic mysteries, linking 3I Atlas to dark matter influences or multiverse echoes, yet grounds it in empirical voids. As data analysis continues, preliminary findings tease at even stranger properties, perpetuating the cycle of investigation. The cosmos watches impassively, holding secrets that may forever elude us.